Have you ever wondered what would happen if you went shopping at a grocery store and then a gorilla came in and started attacking you with bananas?
Well, we have as well, which is why we are going to tell you how vehicles fly by using the concept of fluids.
First, what is a fluid? A fluid is a substance that has no fixed shape and yields easily to external pressure. Most of the time it would be something like water, but air also counts as a fluid.
At first, you think that something like a jet or a helicopter would be unflyable due to its immense weight and size. But with the with the concepts of fluids, that makes it possible. But how do fluids make it possible?
In order to understand how this is possible, we have to talk about the shape and motion of the wing. An airplane's wing is shaped and tilted so that air moving over the top of the wing travels faster than air moving underneath. This difference in airspeed is the key to flight.
I'm Kev's kitty cat. Meow. I get Mr. Rush. I'm back. Anywho, Bernoulli's principle tells us that when the speed of the fluid increases, its pressure decreases.
This is Bernoulli's equation, as seen here. P stands for the pressure to fluids, measured in pascals. P or Fro stands for the density of the fluid. V is the speed of the fluid, measured in meters per second. G is the acceleration due to gravity, which is 10. H is the height of the fluid above a reference point in meters.
Now let's see how to calculate how a plane takes off. Let's say we have the Buckingham Pyro from Grand Theft Auto 5. The mass of the airplane is 14,000 kilograms. The wing area is about 63 meters squared. The air density is 1.2 kilograms per meter cubed. The average coefficient of the lift is equal to 1.5, and the gravity is 10 meters per second squared. To find the weight of the plane, we have to use mass times gravity, meaning we do 14,000 times 10 to get 140,000 newtons. In order to take off, the lift force must be at least equal to the plane's weight.
So let's calculate it using the lift equation stated here, which is 1/2 times air density, which is 1.2, times velocity top minus velocity bottom squared times the wing area times coefficient of lift, which is 1.5. In this case, the plane won't have enough lift in order to take off. So in order to calculate this, we need the speed of the air below the wing, which would be 40 meters per second. We need the speed of the air above the wing, which is 60 meters per second. After solving for that, you square the speeds to get 3,600 on the bottom or above and 1,600 below. You find the difference between the two speeds, which is 2,000. Then you plug it into the lift equation in order to get 112,500 newtons, which is less than the weight of the plane, which is why it'll be unable to take off because it doesn't have enough lift force.
For this case, we're going to be looking at if the speed of the air around our wing will allow for our plane to fly. In this example, we're going to have an increase in the speed. So the speed below the wing will be 50 meters per second, but the speed above the wing will be 80 meters per second. When we square these speeds, we get 80 times 80, which is 6,400, and 50 times 50, which is 2,500. When we find the difference of these speeds, we find the difference of 3,900. When we plug it into the lift formula, we find that the new lift is 221,130 newtons. Because the lift is greater than the weight of the plane will now fly.
Now, in order to properly understand everything that goes into making a plane fly, we need to talk about Newton's third law. Bernoulli's principle is not the only reason planes fly. The wings are tilted slightly upward, which causes it to push air downwards. According to Newton's third law, when the wing pushes air downwards, the air pushes the wing upward with an equal and opposite force. And there's a momentum equation to explain this, where force equals change in momentum divided by time. This upward force contributes to the lift.
Why do planes need a runway? Planes need a runway because lift depends on speed. At
Phew!
low speeds, there's not enough pressure difference to make momentum change or overcome gravity. Once the plane reaches its minimum takeoff speed, lift becomes equal to the plane's weight, which allows it to leave the ground.
Now, what may cause a plane to stall? If a plane is slows down too much, the lift force becomes smaller than the weight. When lift force is less than the weight of the plane, it will cause it to stall.
Now, what's the big picture summary?
Oh, I've been hit!
In summary, airplanes fly because their wings change the motion of the air.
Oh, shoot.
Faster moving air above the wing lowers pressure.
Get him, John!
This lower moving air below raises pressure and air is pushed downwards. These effects combine to create lift, and when lift equals or exceeds weight, the plane flies.
Flight is possible because moving air obeys the laws of physics.
Ah, Let go my
Using air-
parachute!
Now, let's do another example of this with the calculations. Let's say the mass of the airplane is 10,000 kilograms. The wing area is 50 meters squared. The air density is 1.2 kilograms per meters cubed. The average coefficient of the lift is equal to 1.5. But just because I'm feeling a little spicy today, let's make gravity 9.8 meters per second squared.
Step 1. Find the weight of the plane. Weight equals mass times gravity. And with mass being 10,000 and gravity being 9.8, this gives us 98,000 newtons. This is how much upward force or lift the plane needs
I've had
in order
enough
to
of this.
fly.
Back up. What is that? Oh no! Don't do it, please!
Oh no, it's not working! Get out of here!
To solve this, we're going to use the lift equation again. First, we're going to find the speed of the air on top of the wing, which is 60 meters per second, and the speed of air under the wing, which is 40 meters per second. We're going to square both of them to get 3,600 and 1,600. We're going to find the difference between the two, which is 2,000. We're going to plug that into the lift formula in order to get 90,000 newtons, which is less than the plane weighs, so it won't be able to take off.
So this is a short summary just for the end of the example. So slow speed leads to small lift, which leads to no flight, whereas high speeds leads to a large lift, which leads to takeoff. And the lift must be at least equal to the weight.
What are we saying?
Just,
We're all saying.
Just say like thank you, right? 3.
Do we all say thank you?
Yeah.
Wait, I'm writing in the dog. Thank you for. What should we say? Thank you for.
We don't need it. We don't need a script for the thank you, bro.
Okay, my bad, bro.
All right. Thank you all for listening. We appreciate your attention.
Thank you!
Thank you.
Goodbye.
Adios.
I'm Kev's chunky cat. Meow. I can't.